very, very basic overview of how we map the sky. Now, the first thing you want to see is how we map the Earth. The Earth is divided up by these various lines. We have lines of latitude. It's kind of like a ladder is the mnemonic for that. And those, go start at the equator, which is 0 degrees latitude, and then it goes upward towards the North Pole, getting higher. And if you're at the North Pole, it's 90 degrees latitude. If you're at the South Pole, it's negative 90 degrees latitude. And here in Michigan, I'm at about 42 degrees latitude. The other lines on this globe are longitude lines. They go all the way from the North Pole to the South Pole. And we actually have a place in Greenwich, England, the one of those lines that goes through the Greenwich, England is called the prime meridian. That's got 0. That's what we call 0 degrees. And they go around the Earth this way. So 30, 60. Here in Michigan, we're about at 83 degrees west longitude. We have an actual similar map of the sky as if the Earth were inside of a beach ball that looks like this. And these lines are very similar to the lines that we have on Earth. Instead of the equator, we have what is called the celestial equator, which literally is a projection of the Earth's equator out into space. Instead of the prime meridian, we have right ascension equals 0 degrees. And that goes right through what is called the spring equinox, which is what I'm going to talk about. What the heck is the spring equinox? What part of the sky is that? Why is that special? And we'll ultimately get to, at the very end, the punchline is going to be why it is right now the age of Aquarius. The Earth is inside that beach ball globe. So if you take a look at this, what you'll see is the equator of the Earth. If you could stretch that out into a big disk and it projected out to infinity, it would actually intersect this celestial sphere. You got to imagine like the Earth inside of a giant clear beach ball. It would intersect what is called the celestial equator. And this is kind of a better view of it right here. And you can see that here's the Earth's equator right here. If you projected that out, that would actually hit like this disk that is right here is called the celestial equator. It's this one right here. This line right there, 0 degrees, that's called the celestial equator. That's going to become very important later. You also will see that there's something called the North Celestial Pole. What that is, if you stood on the North Pole right here, stuck a stake in the North Pole, the exact top of the Earth, and followed that stake upward, it would actually point to the North Star. And that is what is at the North Celestial Pole. If you want to talk about where stars are above or below the celestial equator, those are called lines of declination. This is 30 degrees declination. This is 60 degrees declination up here. At the very top of the celestial sphere is the North Star
at 90 degrees declination.
At negative 30 degrees is right here. Negative 60. At negative 90 is the south. There's actually no star that's at the south pole of the celestial sphere. We're kind of lucky here in the north. We happen to have at this time in our in the human evolution, we got one star that's really, really close to that North Pole. Right there, and that's Polaris. You put the Earth right in the middle of this sphere here. We're like on the inside of a big beach ball. You can pretend that all the stars, planets, and everything are static on this big old beach ball that we're inside of. Now, that's not really what's happening, but it's a way that we can talk about different parts of the sky. So here's our celestial equator, the projection of the equator out into the sky. And then you can go upward from that celestial equator up to the North Pole, or you can go downward from that. The celestial equator is 0 degrees declination. And you can also have these lines right here that are lines. Okay, now this ecliptic, I'm coming back to what the ecliptic is. We'll see that in a minute. But there's also these lines of what are called right ascension. And it's interesting, instead of degrees, we measure these in hours. Notice here's 0 hours. 0 hours is going to go right through what is called the spring equinox. It's where the celestial equator hits the ecliptic. I will talk about all that. That's at what we call 0 hours. If 0 hour line is right above you, you wait an hour, and then the 1 hour line will be right above you. You wait 2 hours, the 2 hour line will be right above you. They do correspond to actual hours. And as you can imagine, there's 23 hours, and when we get back to 0, it's 24 hours for the entire day. Now, the Earth spins around, the sky doesn't, but it sure looks like the sky spins around. And that's why we have this situation like here. Now, to us, it looks like the whole, we're on a flat surface. So we don't see the curvature of the Earth. To us, it's this flat surface like right there. So if you looked north, you would see above the horizon over here is Polaris. You would look just straight north and look up some number of degrees. In fact, if you know your latitude, I'm at 42.
So if you look upward 42 degrees above the northern horizon,
you will see the North Star there.
So here is just one example of how you use this coordinate system, which is called the equatorial coordinate system. Right here is the celestial equator. That is considered 0 degrees declination. And right here is right ascension 0 hours. You can see that goes right through the spring equinox, which is where the sun is on March 20th here. So let's say we want to find a star such as Algol. Algol is the ghoul. It represents Medusa's head. Let's say we want to find that. So what we do is we look up on the internet, where is Algol, and we will find that it is at about 3.2 hours right ascension and about 41 degrees declination. So let's start here at 0 hours right ascension. Here's 0 hours. Here is 1 hour, 2 hours, 3 hours. So it's somewhere along this line here. And it's at 41 degrees declination. So here's 20 degrees, there's 40 degrees, there's 41 degrees. Hey, that must be it right there. Let's find out. Sure enough, that is Algol. So this system can be used to find anything on the sky. Although this sky does appear to move, these coordinates do not change. For stars and galaxies, if you look up the coordinates for Algol in another 100 years, it'll still be about the same. However, planets, they will move around on this celestial sphere. So those will not have permanent locations, but you can find out where they are tonight. The most important part that we're going to need today is you just got to understand the celestial equator, the projection of the Earth's equator outward. That's just 0 degrees declination, celestial equator.
and the north celestial pole is at 90 degrees declination. That's pretty much all you need for this presentation.
I want to talk about where we are in the universe, okay? And just to give you some perspective on where we are and what we're going to be looking at, this is actually a 3D rendering of this, and I put it should be set at half speed here, so we can go slow, and yeah, it's set. And so here we are on the Earth, and we're zooming out here. That's 10,000 kilometers in width is the Earth. It's about 6,000 miles or so. And then what you'll start seeing is, okay, the Earth is actually orbited by the moon, and you can see the scale of that. The Earth is kind of tiny compared to the orbit of the moon. That's about, it takes light even about a second to get all the way to the moon, approximately. So when we look at the moon, we're seeing light that's a second old. Now, the Earth, this bigger picture right here, I'm going to stop on this for a minute, because does anybody recognize what we're looking at right now?
Yeah, the planets circling the sun.
Yeah, the planets circling the sun. And what I want you to notice is that you see how these are all mostly, not all of them, but they're mostly in one big plane. Looks like kind of a big dish right here. It is not, by the way, it's not parallel with the galaxy. There's an angle, it's like a 60-degree angle with the galaxy, but these are all the inner planets. So we got the sun, Mercury, Venus, Earth, Mars. Jupiter, I think, is probably out here too. I'm going to go even farther out. Whoa, what is going on with those things? We got Pluto, we got the Kuiper Belt, and we got some other weird things going on. You'll notice that Pluto, it orbits in a ellipse that is not in the plane of our solar system. Everything, just to see this again, all the planets are in one plane. That plane is called the ecliptic plane. It's a very important concept, but all you got to remember is that the ecliptic is simply the plane of the solar system. Pluto is not quite orbiting in the ecliptic. That was one of the reasons they decided to not call Pluto a planet anymore. It's a planetoid nowadays. So I'm going to go back from this, and so we can see the bigger picture of our solar system. You can see those are some of the probes that we've sent out. There's the other planetoids have really large orbits compared to the Earth. It's even much bigger than Pluto's orbit. Those are also planetoids, not considered planets. Now we keep backing out here. We're backing out to the bigger picture. This thing is called the outer Oort cloud, which is probably where a lot of the comets come from. And we don't see them for a long time. And every couple of hundred years, or every couple of dozen years, or every couple of thousand years, they come back, and those comets actually leave a lot of dust, and that's why we see meteors. So as we back out farther, these are the stars that are near our sun. Alpha Centauri right there. Right near that is Proxima Centauri. There is some weird message coming from Proxima Centauri that was just found a couple of weeks ago. We don't know what it is. It could be space aliens. It literally could be space aliens. Procyon and Sirius, these are the dog stars. When you see stars close together in the sky, they're not necessarily close together, but these are. Procyon and Sirius are literally close together, and there's two of the closest stars to us. And if we keep backing out, you see some other cool stuff. Okay, some other stars you might recognize, Vega, Capella. Okay, right there, you see this right there? That is the seven sisters, otherwise known as the Pleiades. And if it's dark out right now, you're going to be able to go out, and I'm going to show you where you can find Pleiades today. It's one of the coolest things you're going to see, and I've got a really cool story about Pleiades that I'm going to get to in a minute after we see the big picture here. The Pleiades may be related to the oldest story ever told, a story that's over 100,000 years old. We're in the Orion arm. There's the Orion Nebula. That's the when we look up at Orion tonight, you'll be able to see that with the naked eye. And then we keep backing out. This is the big picture of our entire galaxy. Now, this galaxy is gigantic. It takes light many hours to get to Pluto. It takes light hundreds of thousands of years to get across this thing. So I'm going to just switch over. So the Milky Way galaxy, it's only about 13 billion years old. Our Earth is about 5 billion years old, 4 or 5 billion. And you can see this is about 125,000 light years in diameter. Now, what the heck is a light year? A light year is how far light can go in 1 year. It only takes light about a second to get to the moon. It takes light about 8 minutes to get from the sun to us. It takes light over 100,000 years to get across our galaxy. It is gigantic, or how far across it is. Like, for example, in Star Trek, they never get out of the galaxy. Unless we figure out a way to use black holes or wormholes, we probably will never get out of the galaxy. It is so big. But I mean, there's still plenty of room and plenty of cool stuff. And I did want to show you the rest of the way out here, going out from the galaxy, so you can see the big picture of our entire universe. As you back away from our galaxy, you'll see that there's a couple of other galaxies nearby. The Magellanic Clouds, those are really only visible from the southern hemisphere. But those are little mini galaxies orbiting our galaxy. And then when you look farther away, there's even other galaxies that are orbiting us. And then we're going to see, so the Andromeda Galaxy is right here. That's our biggest and closest big galactic neighbor. You're going to be able to see the Andromeda Galaxy later in the spring or in the summer with the naked eye. I will show you how to find that. So this is like the farthest object that you can see with the naked eye. It's 2.5 million light years away. When we look at Andromeda Galaxy and you can see with the naked eye, you're seeing light that's over 2 million years old.
You said that's also the closest one to us, or it just happens to be the only one we can see?
That is the only one you can see with the naked eye. You can see the Magellanic Clouds. Those are kind of like dwarf galaxies. And you can see some other structures, but this is the only galaxy, full-on galaxy, that you can see with the naked eye. Best viewed late spring or summer.
Is that because it's the closest?
Pretty much, yes. It's the closest, and yep, that's it. That's why you can see it with the naked eye, because it's the closest.
Okay, thank you.
There's some closer, but they're not as bright, so they're tougher to see. And you can see that over here, there's a Ursa Major group of galaxies over there. And we're just going to let this run for the rest of the time. And I'm going to go full speed here just so we can see the big picture of how this is set up. You can see these little strands. Those are all strands of galaxies that seem to be connected together. And there's these giant voids that are many, many galaxies across that there doesn't seem to be a whole lot in there. So this is the actual structure of the entire universe as far as we know it. Now, what's really cool is that we may only be able to see, I'll just let it zoom in, we only be able to see a small fraction of the universe because we can only see as far as, because the universe is expanding. In fact, the way the universe is expanding, some points on the in the universe are actually moving faster than the speed of light away from us. Now, you may say that's impossible. What's happening is space is stretching out. Space is expanding, so there may be some parts of the universe that we will never see because it's moving away too fast. And that is a problem for future astronomers. At some point, they won't even be able to see anything except our local group of galaxies. So we're in a really optimal time right now because we can see all these galaxies and we can see a whole bunch of the universe, even if it's not the whole universe. Okay, we did that. Great. Now, what I want to do is start talking about the specifically the ecliptic plane and what that all means and how we're going to use the ecliptic plane. And that is right here. This thing right here, I got this out of a great book by H.A. Rey. H.A. Rey is the guy that wrote Curious George, but he also wrote a fantastic book about the stars that I highly recommend. It's How I Learned About the Stars. Now, here you can see right here, this little ring here, this represents the ecliptic plane. Now, you can see the Earth, that's the Earth's axis right there. The Earth is actually not, it's tilted 23 degrees from the ecliptic plane. That's why we have seasons. And I'm not going to talk about that today, but if anybody wants to know, I can explain why we have seasons. What I wanted to show you here is this. If you projected out the equator, boom, it would hit this thing. There's the celestial equator right there, marked right there. And then even more importantly, in this plane, the plane of the solar system, where the sun is, where the Earth is, where Mercury, Venus, Earth, Jupiter, Mars, Saturn, all those planets are in, all the plane of that, if you project that plane outward, it hits the sky in some very special constellations. Those constellations are called the Zodiac. The Zodiac, as you may know, if you know astrology, consists of a whole bunch of stars. The reason they're so important is because when you're looking at the sun from the Earth, or you're looking at any of the planets, because these are like the background for the ecliptic plane, you always see planets and the sun in the Zodiac. Because anytime you see a planet in this plane at all, you look behind it, there's going to be one of these constellations that are in the Zodiac. So anyway, this is the ecliptic plane, and that's how you can, on the celestial sphere, in the ecliptic plane, where all the planets are visible, you'll see all the planets will be in one of these constellations, which are the constellations of the Zodiac, your astrological signs. I did want to talk about the Zodiac briefly, and then we're going to get to, right after this, I'm going to give you guys a tour of the sky and how you can find all the stars. But I did want to give you a couple of really cool things about the Zodiac. The ecliptic is the other name for the plane of the solar system, and that's the same thing as the plane of the Zodiac. All the Zodiac is in the ecliptic. As the Earth goes around the sun appears in front of different zodiacal constellations. We can't see the zodiacal constellations where the sun is. Of course, the sun's too bright. It's daylight. So if you're a Leo, you look up in the sky on your birthday, you cannot see a Leo because the sun is in that. Really, it's close to it for reasons I can talk about later. That's the punchline at the end. But you can't see your sun sign on your birthday because the sun is in your zodiacal sign. Now, there's a great, if you want to know all the stars in the zodiac or all the constellations, H.A. Rey, the guy that wrote Curious George, he made up this great little mnemonic rhyme. It goes, the Ramble twins crab liverish, scaly scorpions are good waterfish. It's totally nonsense, but if you memorize it, then you know the zodiac in order that the sun goes from month to month. And so Ramble twins crab liverish, scaly scorpions are good waterfish. The ram is Aries. The bull is Taurus. Twins is Gemini. Crab is Cancer. Ver, those are actually two. Li is for lion, which is Leo. Ver is for Virgo, the Virgin. Scaly is the scales, Libra. Scorpions is just Scorpio. That's easy. That is for the archer. That is Sagittarius. Good is for goat. That is Capricorn. Water is the water carrier or Aquarius, and fish is Pisces. So if you know this little rhyme, the Ramble Twins, Crab, Liverish, Scaly, Scorpions are good water fish, you can go one by one and say, okay, what should be next in the constellation? You have to go from right to left, the way that the sun goes through the sky during the year. That's a really cool mnemonic that is very helpful. But I want to now talk about what the heck is spring equinox. It happens on March 20th this year. And it's when the sun is at a point on the celestial sphere. It's actually the point where the sun is on the spring equinox is actually called the spring equinox. It's somewhere, near Pisces or Aquarius here. It's soon to be fully in Aquarius, which is why we're entering into the age of Aquarius right now. Right here is the celestial equator. Where that meets the ecliptic, where all the zodiacs are, is right there. That's the fall equinox. Over here is right in the fishes. Of course, so in other words, where the celestial equator meets the zodiac or the ecliptic is what we call the spring equinox. So what's happening is the sun is always, of course, it's always in the zodiac because it's in the ecliptic plane. The sun moves from constellation to constellation over the course of the year. Right now it's in Pisces. Then it goes in about a month, it'll be in the Ram. In another month it'll be in the Bull. In another month it'll be right there in the Twins. You can't see the Twins, the Gemini right there. Then the sun will be in Cancer, then it'll be in Leo, etc. It goes all the way around. It takes a whole year for the sun to go around once. And if you're born when the sun is in Leo, you are a Leo. Well, kind of approximately. The reason it's not is because of, again, the punchline, the precession of the equinoxes, which I'll get to at the end. So, but it's pretty close. If you're a Leo, the sun is pretty close to Leo when you were born. All right, so I wanted to talk about the zodiac and what this spring equinox is. The sun on March 20th will be right on that spot, and that's what makes it the spring equinox. And on everywhere in the world, on that day, the sun rises exactly in the east and sets exactly in the west. It doesn't matter where you are on the earth. That's a way you can find exactly east or west from your house. Okay, now we're going to move into how to find the stars in the sky. And this is the part that I like, because this is, you can go out and without a cell phone, you can find all the cool constellations. And I've developed a mnemonic. I want to just show you guys a little mini version of a mnemonic that you could use to find different stars. If you go out in the early evening, you're going to see Orion. It is typically in the south, and it's one of the most unmistakable constellations you're ever going to see. But what we can do is we can use an easily recognizable constellation like Orion to point us to various stars and various constellations. For example, if you take the belt of Orion and you go follow it to the left, you'll hit Sirius, which is in the big dog, Canis Major. If you go to the right, you'll hit Aldebaran, which is in Taurus. If you go even farther, you'll hit the Pleiades. If you take the two shoulders and follow them to the left, you'll hit Procyon, which is in the little dog. If you take the bottom right foot, which is Rigel, and the upper left shoulder, which is Betelgeuse, follow a line between them, you will hit Gemini. And so here's a picture of that, just how you could use a mnemonic like that to find some of these things. Here are just some of the constellations that you will see when you just look up to the south. Right when it gets dark is probably the best time to check this out, or a little bit after that. You will see Orion is right here, unmistakably. Up to his upper left, if you follow this point and this point, his big foot and his big shoulder follows up, those will take you right to Gemini, the twins. If you take these to the shoulders, follow them out, that'll take you right here. That's called the little dog, Canis Minor, and that's Procyon. You follow the belt down to here, that is Sirius, the dog star, and it's part of the big dog. Canis Major means the big dog constellation. Down here, right below Orion, is the rabbit, Lepus. Over to the lower right of Orion is the river Eridanus, which is a really dim, hard to see constellation. But up here is Taurus, which we're going to see, and the Pleiades, which I have a cool story about. I guess I'm going to go ahead and talk briefly about the Pleiades, because there's just such a cool story. The stars were the TV of the ancients. So yes, we have all these myths. If you look up at the sky, there are so many myths that are really just right there in the sky. I'll be able to tell you a couple later. But one that I wanted to look at right now that is especially cool is the myth of the Pleiades. Now, the Pleiades in Greek mythology were considered the seven sisters. But when you look at Pleiades, you really only see 6 stars. The Greek myth, there's a myth of one of the Pleiades, one of the nymphs, one of these ladies who represent the seven sisters, got lost. The myth of the lost Pleiad. Here's what is weird. So many cultures have a myth of the lost Pleiad. We're talking about Aboriginal cultures in Australia have this myth. Western cultures have this myth. First Nations people in North America have this myth. So there is a paper I checked out recently, an article. A couple of astronomers are positing that what might have happened is, like the myth of the lost Pleiad, these 2 stars right here, they are so close together, they really look like one. If you look up at the sky, you'll see this one, which is a Pleione, and a nearby star. And then you got 1, 2, 3, 4, 5, 6. The 6 brightest stars is all you can see. 100,000 years ago, Pleione was farther away from its nearby neighbor star. So what happened was, at least this is what is posited by these astronomers, is that as the years and the thousands of years progressed, this star got closer to that one, so you could not tell them apart. So what's weird is that all the cultures of Earth have some kind of myth about some Pleiad going missing. And these astronomers are positing that, yes, it was because this myth started 100,000 years ago when humans were just leaving Africa, and all the diaspora of all the humans all retained this myth, and they developed their own version of it, like what happened to that Pleiad, what happened to that star. But it's because, at least according to these astronomers, they believe it's because this star was far enough away 100,000 years ago that you could actually see it as the 7th Pleiad. We've got the Pleiades. Now I want to go on to, for me, which is the most fun, how to find all the stars from the Big Dipper. The Big Dipper, if you wait till late tonight, or maybe just go out in April sometime, you will see the Big Dipper directly overhead. And I'll show you how this works, and how you can get to over 20 constellations if you can just find the Big Dipper. I did the Orion separately because see how Orion's way over here? Orion's going to be right over here. So all those stars are not going to be visible to us later in the night. That's why I did that little thing separately. But so many constellations can be found directly by the Big Dipper. I'm going to go to the Stellarium web. Here it is right here. Oh, I did want to show you a couple cool things. I'm at Stellarium web, but what I did was I put my location, I set it as on the equator. If you're on the equator, this is what the night sky looks like. Everything rises directly in the east and sets in the west. This is if you're looking straight overhead. That's what it looks like, because you're literally, the celestial equator is literally directly over your head. This is the celestial equator. If you are on the North Pole and you look straight up, you see the North Star. The North Pole of the celestial sphere is right above the North Pole on Earth. And if you see this, this is what the sky looks like if you look straight up while you're sitting, laying on your back on the North Pole. Notice that one star does not move. What star is that does not move at all? It is called the North Star. All the other planets, or stars rather, seem to orbit around that as the night goes by. Everything seems to circle around that one star directly overhead. But let's go to more like what we're going to see. This is what you see from my house in Ann Arbor, Michigan. There is the North Star. You'll notice that if you look directly north and go up as many degrees as is your latitude, I'm at 42 degrees latitude, so I just have to go up 42 degrees and boom, there you will see the North Star. But you'll see that all the constellations, as the night goes by, you will notice stars rising in the east, setting in the west, but they're all orbiting around, or appear to orbit around, this one star right there. That is Polaris, the North Star. That's kind of like some First Nations people called that the pin, like the pin of a pinwheel. Like that's where you pin the sky and everything else seems to move around it. Now keep in mind, it's really the Earth that's moving, but we just pretend that the sky moves because it's so much easier for us to talk about it, because otherwise it can get very confusing. So we just pretend the sky moves like that. The sky orbits around the North Star, which is an Ursa Minor, the Little Dipper. Now, what I'm going to do right now is I'm going to actually zoom in to Ursa Major here, and I'm going to get it to I'm going to get rid of this and go to let me get rid of the landscape here so we can talk directly about Ursa Major a bit. Now, Ursa Major is kind of a cool constellation. It's got a lot of cool things going on with it. Ursa Major, and I've kept the constellation lines here. I'll just get rid of them so you can see what this really looks like. It is very easy to find the Big Dipper in the sky. If you look up and you look, later tonight, it'll be very late tonight. It'll be directly overhead, but most people can find the Big Dipper. You can look kind of northward. That might help you. Like tonight, it will be directly overhead. But I wanted to just give you kind of a tour of the Big Dipper because there's so much cool stuff going on here. This right here, this star at the end of the Big Dipper, the end of the bowl, is actually called Doobie. These stars, they all look close together in the sky, but they're not close together at all. Doobie, this star right there, is 123 light years away. That means it takes light 123 years to get from this star to us. Whereas Merak is only 80 light years away. So these look like they're close together, but they're really over 40 light years apart. Okay, so we got to be careful. We might be fooled by seeing stars close together. They might not be close together. But here's something very cool. Merak, Thad, which is also called Phecta, Megrez, Alioth, and Mizar. These 1, 2, 3, 4, 5 stars. I'm not sure why they're not labeling Megrez there, but these 5 stars, Merak, Phecta, also called Thad, Megrez, Alioth, and Mizar, they actually are close together in the sky. They are all together, and we call those the Ursa Major moving group. These 5 stars are literally moving towards us at 100,000 miles per hour, and they are all related. They are literally sister stars, just like the 7 sisters are literally sister stars, meaning they were created together, they're made of the same stuff, they're the same age, about. These are all moving together. We call that the Ursa Major moving group. Alkaid is not part of that. These are all like 80 light years away. All of these are about 80 light years away. Alkaid is not. That's closer to, that's like 100 light years away. So Doobie and Alkaid, they don't really belong to this group. They just look like they do. In another 10 or 20,000 years, this constellation, the Big Dipper, will not look like this at all. Doobie will be way over here. Alkaid will be way down here. These 4 will be about the same. They're all moving together. But the Big Dipper is going to look totally different in a couple 10,000 years. Now, the Big Dipper is actually not a constellation. We call it an asterism. It's part of a constellation that's the Big Bear. Ursa Major, the Big Bear. Here's another weird resonance across cultures. So many cultures call this the bear or something to do with a bear. In Greek culture, this is the bear with a long tail that happened when Zeus threw Arcus, threw her up into the sky. That when she got turned into a bear, he grabbed it by the tail, threw it up in the sky. That's how the tail got elongated. But in First Nations mythology, these are 3 hunters, and this is the bear. And they are all following the bear around. In the First Nations myth, these 3 hunters follow this part, which in their myth, this rectangle is the bear. They are hunting it and following it, or the bear, around the pole. You can see how you might think of that as a bear being followed by hunters, because these are visible anywhere in the northern hemisphere any night of the year. They're called circumpolar constellations, including Ursa Major, Ursa Minor, Boötes, a bunch of ones you can see at the end of the year. Now, I did want to bring your attention to this. They said that in the First Nations myth, these are braves. If you look at this star right there, and you can go out tonight and see this, if you look really close at this star, you will see that there's more than one star there. It's easy for us to see this right here because I can zoom in, Most people, if you look a little bit away from it in the sky, can detect that there actually is another star there, Alcor. They also call this the horse and rider. This was used as a vision test in ancient Rome. If you could distinguish that there were two stars there, you were good enough to be in the Roman army. Mizar and Alcor, the horse and rider, but in the First Nations myth, this brave is carrying a pot to cook the bear, and that's what that Alcor is. That's what Alcor is, the pot being carried by that brave. So here's how you get to all the stars in the sky, all the constellations. Find the Big Dipper. And you can start off with my favorite, or one of the easiest ones. I didn't make this up, but if you see the Big Dipper's handle right here, Big Dipper's handle is an arc. If you follow that arc will take you to Arcturus. That's the first little memory device. Follow the arc to Arcturus. Now, what is Arcturus? Arcturus is part of Boötes. Boötes is called the Herdsman. I don't particularly like this drawing of Boötes. H.A. Ray, the guy that wrote Curious George, in his book, it actually looks like a person. Boötes is the herdsman. Now, how do you get the name the herdsman? Well, if you just, again, follow the stars through the sky at night, that herdsman is following the Big Dipper all around the sky. It's kind of like it's herding the bear. Arcturus translates as the bear follower, so it makes a lot of sense that this herdsman is somebody who just follows his animals around, and he's following the big bear around. Now, the next mnemonic is if you follow the arc to Arcturus, you can go straight down from there like a spike to Spica. That star right there is called Spica. Another one of the brightest stars in the sky. That's like the 16th brightest star in the sky. And most of the stars that we can see are either like tens or hundreds, rarely thousands of light years away. So almost everything we can see is a couple hundred light years away. Spica is 260 light years away. So arc to Arcturus, spike to Spica. I'm going to take these off now because Virgo is in the Zodiac. We've already made it to the Zodiac, but I will show you how to find other stars in the Zodiac as well and other constellations. So review, arc to Arcturus, which is in the Herdsman, Boötes, spike to Spica. Spica is the brightest star in Virgo, the Virgin. Now, if you take this arc to Arcturus right there, and then you skew off to the left, arc to Arcturus, you could go to Spica, or you could skew to the left, skew to the Scales and the Scorpion. Skew to Scales and Scorpion, because the Scales and the Scorpion are right over here. And once we get to the Scorpion, we are seeing the Milky Way. This is the plane of our galaxy. We are in the Milky Way, so we're kind of in the middle of this disk. That's why it surrounds us. Now, you may say, well, why are all these stars not in the Milky Way? Here's a really good perspective. They are in the Milky Way. All these stars to the right and all these stars to the left are in the Milky Way, but they're just so much closer to us. Imagine all these stars that are close to us, but are a little off to the left. We're really close to them, so we kind of see them out of the Milky Way. These stars are very close to us, but a little bit to the right. They are in the Milky Way. It's just that they're so close that they appear above or below or to the left or the right of the Milky Way. All of these stars, everything you see tonight, everything is in the Milky Way galaxy except for the Andromeda Galaxy. Thank you. The Andromeda Galaxy is the only thing that is not in our galaxy that you will see tonight. Okay, now let's go back to the Big Dipper. Here's the left side of the bowl. Take the left and go lower. You'll eventually hit a really bright star right down there. Left, low, Leo. All the little hints are meant to help you figure out what you're doing. Left, low to Leo. Leo kind of looks like a question mark in the sky. If you just look at Leo, you'll see a backwards question mark mainly, but you can kind of see his tail over here. That star is called Denebula, which means tail of the lion, sure enough. But you'll see kind of a hook right there, or a question mark, and that is Leo. It kind of does look like an animal of sorts. You got its head, its front paws, its tail, or its back legs. So that is from the Big Dipper. on the left side of the bowl, left low to Leo. Then you might ask, what happens if you go on the left side but go higher? Left higher goes to Lyre. The Lyre, or the Lyre, Lyra is the name for the constellation, is the stringed instrument that was played by Prometheus, I believe, when he went down to hell to try to rescue his girlfriend. He went down there and tried to play such a sweet song that they let her out. My mythology could be kind of weak on that. But again, left low to Leo, left higher to Lyre. And that star right there is pretty much one of the brightest stars you'll see. That's Vega. That is the 5th brightest star in the sky. So it's usually right overhead in summer. So if you look straight up, you'll see Vega. There are a couple of other cool things that you can do from the Big Dipper. So left low to Leo, left higher to Lyre. Let's look at the cap of the bowl here. Here's the bowl. If you take the cap of it and then go outward from the cap, kind of like away from the handle, cap will take you to Capella. Cap to Capella is the brightest star in Auriga, the Charioteer. Here's another cool one. Let me move it over here so you can see all this. If you do the diagonal right here, like you would pour out of the Big Dipper, if you tilted the Big Dipper, it would pour out this way. From this corner out to Doobie, out that way. If you find out which way it would pour, that will take you to Perseus. Now I did want to mention right here, this is ancient TV. This is what, people like us would do this is what people like us do for fun now, but the ancients also did this for fun. They would just go out and lay down on the ground and figure out what the heck is going on here. Because some things, everything kind of passes by during the night. If you just, if you watch it during the night, things do change, kind of like this. This is the sped up version. Things change exactly like that. Like, what is going on? What is the story here? So you can imagine how the ancients might make up stories. And I'm just going to tell you one story that I think is really cool. And it is, you can see these almost every night of the year, which is why it's a really good story to tell. So again, to get to the story, pour to Perseus, and this is the myth of Perseus. Now, what I'm going to do is actually, let me get you to the other characters in the Perseus myth so you can find all of them. So this is probably the most important mnemonic in the whole thing. And this is probably the one I should have done first, because this is the one that can save your life. The most important star in the sky that you need to survive is the North Star. The North Star is right there. You may recall, this is the star that everything seems to be turning around. If you just watch the North Star in the sky, it doesn't move during the night while everything else does. And it takes, for everything to go around once, it takes not quite 24 hours. It actually takes 23 hours and 56 minutes for everything to go around, which is why a sidereal day is 23 hours, 56 minutes. It's also why the sky looks slightly different every day, every night. All these orbit around that star right there, Polaris. All the stars and constellations turn around it once per night, but also once per year. Just to demonstrate that real quick, I'm just going to go forward. This is what it looks like tonight at midnight. If you go forward a month, it looks like this at the same time. You go forward another month, it looks like this. It seems to be spinning around also over the course of a year. So these stars go around the North Star once per night and also once per year, because they advance a little bit by 4 minutes every night. Okay, here we are, 3:13 again. Okay, here's where we are now. This is set at midnight, which is a little bit, let's set it right. Okay, this is now my current time, about 9. And all right, back to the Perseus myth. So the most important star in the sky is the North Star. Why? Because at least during our lifetime, that is going to be directly north. That is actually more accurate than a compass in most places in the United States. If you use a compass in Michigan, it'll point 6 degrees northwest. If you use a compass in California, it points like, 16 degrees northeast. It's not north at all. If you want to go north, find the North Star. Here's how you do it. You take these two stars right here, which are Doobie and Merak right there. You take those two stars, they're called the pointer stars. You follow them, boom. The next star you see is that it's not one of the brightest stars in the sky, but it is a relatively bright star, is the North Star. The North Star is the end of the handle of Ursa Minor, the Little Dipper. So I'm just going to do this so you can see what it actually looks like. Here's your Big Dipper. You follow these 2 pointer stars, boom, right there. That's the North Star. Now, I've heard a lot of people, unfortunate amount of people say, oh, the North Star is easy to find. It's the brightest star in the sky. False. It's not even in the top 20. I think it's like one of maybe the top 40, probably in the top 40. It's not the brightest star in the sky at all. You just got to follow these 2 stars to find it. Once you find it, if you walk towards that star, and I will put the landscape back so we can see it, if you walk towards that star, you are going north. And that will be true everywhere in the northern hemisphere. You can't see it from the southern hemisphere. So anyway, that's the most important star in the sky because that'll tell you where you are. Also, if you're like lost at sea, if you can figure out how many degrees upward that is, that'll tell you your latitude. For me, it's 42 degrees above the horizon, so I'm at latitude 42 degrees. Pretty cool. Now, here's how you get to the rest of the stars in the Perseus myth. You follow the pointer stars of Ursa Major to the North Star, and you keep going. Boom! The next star you hit is called, that is Auriga, E-R-R-I-A-I. That is the top, one of the brighter stars in Cepheus. Cepheus may be based on Cheops, the king of Egypt, but Cepheus is the mythical ruler of Ethiopia. If you follow that and you kind of follow that, it will take you, the sky is curved. It's hard, it's hard to see in 2 dimensions, but if you keep following it, it goes through the North Star, through this star in Cepheus, the king, and it'll eventually hit this star in Cassiopeia, the queen. So this is the king of Ethiopia. This is his wife, Cassiopeia. How to see Cepheus, it's kind of hard to see, but it kind of looks like a face. Here's his eyes. There's the top of his hat. He's got kind of a little smile down here. There's the bottom of his face. That's kind of his nose. The queen is even harder to see, but if you imagine this is her head, that's her butt, that's her knee, and there's her foot, and she's sitting on this platform. She's seated on a throne. That's how you can imagine Cassiopeia, the queen. But Cepheus and Cassiopeia gave birth to the princess Andromeda. Now, Andromeda, you can actually see the Andromeda Galaxy in here. But here is just the brief myth. Perseus was on many, many adventures, but on his way back from slaying the Gorgon, who was called Medusa, you may have heard Medusa. Medusa, everything that Medusa looks at turned to stone. What Perseus did is he held up his shield and reflected Medusa's image back at her.
And then he cut off her head with a sword.
And here's the thing. This star right here, that is Algol. Algol means, it's Arabic for the ghoul. Now, here's a cool thing. Why is that called the ghoul? These ancients, they were paying very close attention because Algol gets brighter and dimmer over the course of 3 days. So when you're watching this every night, you go, wait a second, that's dimmer tonight. And you keep seeing it. That's why it's called, they probably called it the ghoul, because what the hell's going on with that star? It keeps getting brighter and dimmer. There must be some magic going on there. And then there's other cool stuff. So he's got Medusa. He's carrying Medusa right there. What he does is he sees Andromeda there. She's chained to this rock. He sees her and sees the whale. Here's the whale. Cetus the whale is the monster that's coming to eat her. By the way, the reason the monster's coming to eat her is because Cassiopeia pissed off Hera by saying, Cassiopeia said that she was the most beautiful in the world. That pissed off the gods. So they sent this monster, the whale, to go destroy the city that Cassiopeia and Cepheus were the monarchs of. So they had to sacrifice their only daughter, Andromeda, to this monster to get the monster, Cetus, the whale, to stop bothering the city. But then Perseus saw this. He rushes in. He shows the ghoul, the face of Medusa, to Cetus, turning Cetus into stone. And then he rescues Andromeda, unchains her, and they eventually get married. Now, here's kind of a cool tidbit. Perseus ends up not only killing Cetus, but eventually he goes on to kill Cepheus and Cassiopeia. But here's the weird part. The reason that this myth may have developed is Algol is a variable star. It gets brighter and dimmer. there are variable stars in Cetus. There are variable stars in Cassiopeia and in Cepheus, meaning that the ancients might have said, wow, we keep seeing these flashing lights. The myth may go is what Perseus did is he put the head in a bag, this magic bag that would protect it and wouldn't let anybody see it. So when the head is coming out of the bag, that's when it flashes brighter. So that may be the reason that this myth developed, because all of these constellations have stars that are variable. They get brighter and dimmer that may be visible with the naked eye, especially back when there were no light pollution back in the day. So you can see how the ancients made up all these stories based on all these characters that they saw in the sky. Anyway, that is the Perseus myth, which is very, very cool, and how it all connects with the actual astronomy of it. Anyway, let's continue with the mnemonic here. So here's the Big Dipper again. Here's another cool mnemonic, one of my favorite. You see how there's these three in the handle. The handle, there's like three in a row that are almost collinear exactly. If you take those three, follow the handle to Hercules, boom, you will see it's actually easier to find on the actual sky than it is here. Handle, these three go straight to Hercules. Here it is right here. These four stars. Let's go ahead and look at the constellation right there. Hercules is called the kneeler in some cultures, in some First Nations, because his head is right there. There's his shoulders, but it looks like he's bending his knee right there. There's one leg. There's a bent knee. He's called the kneeler. He's got like here's one arm, the other arm. He's got a shield, but handle to Hercules. Now Hercules is cool because I remember I said there's only one thing that you can see in the sky that is not in the galaxy. That's the Andromeda Galaxy. I'll go back to that in a minute. But there's one thing that you could argue is that you can see with the naked eye. You could argue it's not in the galaxy. It's right here. If you look at Hercules, look under his right armpit. There's something called M13. It is the Hercules globular cluster. You can see it with the naked eye. It just looks like a little tiny puff of light, but M13 means Messier 13. It's the 13th object in the Messier catalog. But what that is a globular cluster. Now, globular clusters are cool because when we look at the plane of the galaxy, everything's in the plane of the galaxy, the flat plane, except for there's these little mini spheres that are kind of shooting above the galaxy, then below, then above, and they're all spinning in like really different ways. But those are like kind of little miniature galaxies of their own called globular clusters. They typically contain, a couple 100,000 stars, but they may have actually joined our galaxy later. They are not in the plane of the galaxy. They like circle around the center of the galaxy above and below. So you could argue that it's not part of the galaxy, even though it's circling the center of the galaxy. But that's something you can see with the naked eye, the Hercules globular cluster. It does look like a glob. It is spherical, and it is a cluster of hundreds of thousands of stars. So Hercules globular cluster, again, to get there, handle to Hercules. Here is the three that point in a line that are collinear. Take that to this big rectangle is recognizable in the sky. It's called the keystone. And if you can find that, that is the shoulders and waist of Hercules. Let's keep going with the mnemonic. Where does it go next? I do want to go show you a way that you can get to actually find Andromeda and find the Andromeda Galaxy. Again, if you take the pointer stars to the North Star and keep going, you can't really tell in here, but the sky curves. And if you follow this line, it'll curve with the sky. This is the side of the Great Square of Pegasus. Andromeda's head is right there. Let's go ahead and look at Andromeda here. There's her head right there. She is chained up right there. There's her butt and her legs right there. But if you look out at her knee, where you want to look, and you may have to look a little bit askance of it, but out at her knee, if you look just a little bit, it kind of looks like that in the sky. It's a little puff of light. That is literally the Andromeda Galaxy. There's a big close-up of it. So that's our nearest neighboring galaxy. It is a little bit bigger than our galaxy. That is actually moving toward us. Most of the galaxies are moving away from us as the universe expands. The ones that are close to us, that guy right there is moving toward us. In about 5 or 10 billion years, We're going to crash with it. It's going to slam into us. Here's the cool thing. Even though our galaxy is going to slam into the Andromeda Galaxy, the space between the stars in our galaxy is so massive that these two galaxies are going to go right through each other and completely miss. There will be no actual collisions. There might be a couple collisions here and there, but for the most part, there will be no collisions when our galaxies collide with each other. They will affect each other. Everything will affect each other gravitationally, but everything is so spread out in our universe that there may actually be very few or no actual collisions of stars. That's how far things are spread out.
Keep an eye on the Andromeda Galaxy as we view that same collision, but from Earth.
Fun stuff there, Andromeda Galaxy. I find Andromeda the best in late summer. Late at night in late summer is when I'm up and when it's out. So that's probably the best time that I found to see it. Back to the mnemonic, doing more of the mnemonic. Here's another one. If you take the diagonal, now remember the way it pours out, pour goes to Perseus, but the diagonal, the other way, this way, will point you, and by the way, many of these pointers are pointing away from the handle like this one. The diagonal will take you to the dynamic duo. The dynamic duo is better known as Gemini. And now we are back in the zodiac. Here's Gemini, Cancer, Leo. All those, by the way, you can find them just under the Big Dipper. Left low to Leo. Take the diagonal down here to the dynamic duo, Gemini. And by the way, if you want to, you can keep flying to Orion. So that's how you find that. So the twins, they're in the zodiac. Let's go ahead and explore the zodiac right now while we got it. The Ram, by the way, Aries is super hard to see. There's just a couple of bright stars that are the Ram. The Ram Bull is Taurus. The twins, Gemini. Crab is Cancer. Li is Lion. Virgo, liver-ish. The ish is just to fill in the syllable. Scaly, Scales. Libra is the Scales. I much more prefer H.A. Ray's drawing of it, which actually kind of looks like Scales the way H.A. Ray draws it. But the Scales are right there. And then you keep going to Scorpion, scaly scorpions. And now that takes us to the galactic plane. Now let's talk a little bit about the galaxy and Sagittarius. Sagittarius is actually right at the center of the galaxy. If you look, you can see Sagittarius. It looks a lot like a teapot. So the steam coming out of the teapot is the Milky Way. So you can see there's like the handle, there's the lid, there's the pot itself, and there's the nozzle or whatever where you pour out, and that steam coming out of there can be thought of as the Milky Way. It's just where most of the stars in our galaxy are. It's all in this big plane. It's only about 1,000 light years thick. Again, these stars are all also in the galactic plane. It's just they're so close to us, they look to the right and to the left of it. So this galaxy, you can follow around as much as you want, and you can get to a bunch of other cool stars that way too. And in the plane of the galaxy, you will find Sagittarius, you'll find Aquila the Eagle, you will find Deneb the Swan. Now the Swan I want to talk about briefly because it's also called the Northern Cross. It's very easy to see, especially in the summer. If you look straight overhead, you will see this cross. That is the Swan. It does look like a bird that's flying through the Milky Way. It really does when you see it. Deneb is a special star because most of these stars are like hundreds of light years away. Deneb is over 2,000 light years away. It's one of the actual brightest stars in the sky. It's so bright that it's even one of the brightest stars in the sky, even though it's so much farther than all these other stars. If you look up, you will see this triangle here. Vega, Deneb, and Altair, those form what are called the summer triangle. There's three of the brightest stars that you can see. If you look right here, we can see where a bunch of these planets are, and you'll see that they are in the ecliptic. I'm going to zoom in. So we left off at, there's Scorpio. So the Ramble Twins, Crab, Liverish, Scaly Scorpions are, R is for Archer, which Sagittarius is the Archer, are good, goat. Good is goat. if you look up there, you will see we've got Mercury, Jupiter, and Saturn. You can see the sun is also in Pisces. By the way, here's Aquarius right here. Again, I like the HA Ray version as well. But on the 21st, now is the sun, as we go forward to the, let's go ahead to the spring equinox, which is 3:20 this year. 3:20, I think it's like at 5 a.m. Now you see how the sun is still in Pisces, but any day, any year now, or anytime in the next 100 or 1,000 years, the sun on this date, on 3:20 of the year, I don't know, maybe 2200 or 2100, is going to be very clearly in Aquarius. That's what makes now the start of the dawning of the age of Aquarius, if you will. And this is, I wanted to finish up with this, so this is probably a good time to do it. I can show you some more constellations if you want, but I did want to at least, and I can go on for hours and hours, way more than you guys would want, but I did want to show you one thing about why it's becoming the age of Aquarius. So here's the Earth, okay, and what we're looking at right there, there's the equator, right? And there's the ecliptic plane. Now the ecliptic plane is the plane of the, again, the plane of the solar system where we'd see the sun and we'd see all the planets, except for Pluto, in that plane. The equator, notice that the Earth, here's the North Pole of the Earth, it's tilted 23 degrees from the perpendicular to the ecliptic. So that's why we have seasons. Now, I'm going to go full screen so you guys can see this. This is a really, truly amazing thing. Now, this thing is going to project out so we can get a better view of this. And so there's the ecliptic plane. They're literally showing it as a plane there. And there's the equatorial plane. So this is what I mean by projecting out the equator of the Earth out into space. Now, if you do that, these both of these planes, you can see, now here's what's going on. The Earth, this is happening, what you're seeing right now, this wobble happens over 26,000 years. It takes 26,000 years for the Earth to do this once. This is just like a top wobbles, the Earth wobbles on its axis, just like a top that's about to fall over wobbles. Now you can see what's happening here is if you look at the intersection, I'll go back to this, the intersection between that equatorial plane and the ecliptic plane, right there, it's right there, that is where the spring equinox is. Wherever the projection of the equator, the equatorial, the celestial equator, wherever that hits the ecliptic plane, that is by definition where the equinox is. And because the Earth wobbles on its axis, just like a top about to fall over, and it does this every 26,000 years, that equinox point moves. It changes what constellation it's in. And what they're going to show you right here is the symbol for the spring equinox is that that little, here it goes right here. Okay, that thing right there, I think that's the symbol for equinox. Notice it changes over 26,000 years. So this is way sped up, obviously. And also you'll notice that the North Star changes. What is directly above the pole? Now in 1 AD, it was in Pisces. Now we're getting closer to Aquarius right now. And then we keep moving. That equinox will be in Capricorn in 4000 AD. In 6000 AD, the spring equinox, where the sun is on March 20, will be in Scorpio, or in 8000 AD. Then it'll be in Libra at about 10,000, and keep circling around Virgo in 12,000 AD. And this whole cycle takes 26,000 years. It's in every single one of the zodiacal constellations over the course of this 26,000 year cycle. You could go backwards as well. 2,000 years ago, it was in Pisces. So this is why the precessions change, and it was in Aries 22,000 years from now, or 4,000 years ago, and it's in Pisces in the year 0. And what happens is the North Star changes. And this is a cool thing. It'll show you how the North Star changes. The North Star just simply means what star is directly above. If you put a stake at the North Pole, what star is directly above that? 2000 BC, it was in Draco, the dragon. Now here we are right now. The North Star, or what is directly above the North Pole, that's where it was 2,000 years ago. That's where it is now. There's the Polaris, the North Star right there. But the North Star is changing. If you manage to live another 2,000 years, Polaris will not be the North Star anymore. It will have advanced to there. And this goes around, all the way around this little circle right here in a 26,000 year cycle. Now, the reason that we are actually out of phase is because with your sun sign, if you're a Leo, the sun is not in Leo during on your birthday. It's like a month or two out of phase. The reason is because astrology was developed 2,000 years ago. The spring equinox was right about there, maybe a little bit before, like in Aries. So everything is out of sync. If you're a Leo, the sun is not in Leo on your birthday. On my birthday, I'm a Leo, but the sun is actually in Cancer during my birthday because everything's out of phase because of this precession of the equinoxes. Every 26,000 years, the equinoxes where the celestial equator and the zodiac intersect, it changes and it goes through all these different constellations. So that's why we're entering the age of Aquarius right now. It may be happening. I mean, they thought it was happening 60 years ago. May be happening now. And I kind of think it's probably really happening now. We're having a lot of resonances with the 60s, and a lot of people are kind of waking up. So there is an argument to be had that this is truly the dawning of the age of Aquarius. Now, I'm going to call it a wrap right there, but I'm going to take any questions you guys. I could keep talking about how to find many other constellations, and I will if you want me to, like the eagle. The eagle kind of looks down on the sea goat. There's a bunch of sea or water types of creatures, like the sea goat. Capricorn, believe it or not, is a goat that lives in the sea. Aquarius is the water bearer. He's picking up water and pouring it back. We've got the whale is in the sea. The fishes, Pisces, are in the sea. So there's a big wet area of the sky as well. And I'm going to just call it a day right there. By the way, just to give credit for this, I got this map right here from skymaps.com. You can get all these. And what the advantage of these kind of maps are, they show you what planets and other cool things are up and visible in the night sky. And thank you so much for coming.
So awesome. So awesome.
Yes, very glad you enjoyed it. If anybody's got questions, I'll be hanging around here until all the questions are done. And there's much more to the sky than I've been able to cover in this hour. And I'm super happy to completely blow your mind when we can really, as soon as possible, I hope we can all be under the stars, really under the stars with each other. I will see y'all there under the stars and give you the real deal. And believe me, the real deal is so much better.